Well, hi again everybody, welcome to my latest video. Well, I'm going to revisit my Raspberry Pi. Remember last I showed, we put it into this case here, which was a pretty good one, and it would have sufficed. But by pure chance, I found a better case for it. And also, I wanted to show the first step in terms of changing the operating system from the existing Raspberry version of Linux to Ubuntu Linux, which is more appropriate for what I want to use this Raspberry Pi for, which is a backup domain controller for my home network. Well, here's the other case. It's called the Argon One. Now, a lot of different manufacturers sell it. I'll put down a link below along with a few other links at the bottom of this video that you can use to access it. I got it at a really good price. You know me, I like to look for sales, and this was going for a rather cheap price. It's gone up about 30% since I bought it. I just checked a couple of minutes ago. But that's okay. I think even at that price that's now listed, it's still worth it. But I'm going to go ahead and show you a few things here today. First, do a box opening of this Argon One case and show you some of the nice features about it, what really enticed me into getting it, and I think making it more appropriate to become my backup domain controller. So hopefully you'll agree. But then I'm going to show you how to load Ubuntu Linux on this. And I'm going to go more in terms of the manual mode. By the way, this is another SD card. I got myself 32 gigabytes that will support the Ubuntu Linux, because I think there's going to be some logging and stuff like that that I'd like it to do, and so we need the extra data space on this in order for that to function properly. But there was the automatic mode, the way I showed you when we loaded onto the SD card that's currently in here. We showed how to load the Raspberry Pi version of Linux. Well, that was done in a somewhat automated mode through the Raspberry Pi website. So I'm going a little bit differently this time. I've downloaded the full image that is the version for the ARM microprocessor, which is what the Raspberry Pi has as its microprocessor. It's called an ARM. That was one that I actually had to study for my PE exam, so I do know a bit about it. Well known in the educational arena, and it's one of the things that college textbooks focus on. Anyway, that aside, we're then going to transfer the Raspberry Pi from this case into this case. And once we have it up and running, then we'll do the manual update of this SD card to have Ubuntu Linux, and we'll see, you get to see all the different ways you can do it. Now that's nice just in case you're ever in a situation where you cannot get online, but you happen to have the image of one of the operating systems, whether that's a Raspberry version of Linux or one of the other versions of Linux that are available out there. You can actually load it onto the SD card without having online connectivity. And that's the mode I'm going to show you today. Let's do the box opening of this new case. Okay, here's the new Argon One case that I found. It has those really tough tapes on it, so I needed to get my Swiss Army knife. Cut these open. It's inside of a nice package. It has some instructions in here. Oh, the installation and assembly instructions. I'll have to read through that. It actually has a nice feature that I'll show you. It has a real power button, and the power button is set up so that it will do a real soft shutdown of the Raspberry Pi. Now hopefully that still works with Ubuntu Linux, but we'll test that out and find out. Okay, well, like I said, I'll read through that. Not a lot, but something. Let's see what we got when we open this thing up. Okay, so this is the bottom of the case. This is the top. And the top is supposed to have a magnetic door. Yep, it's pretty nice because this door allows you, if you'd like to do experimenting with it, you get full access to the 40-pin I/O connector. And you can then, of course, put a connector on it. It's keyed over to a breadboard. And I'll show you that in future videos, how that's done and how you can use that for doing some experiments. But this one also lays out for you very clearly what each of the pins are. That's really handy. But when you're using it normally, like I will, you just put this back in place and it locks. It's got the power in here, and it has a power button. So this power button, it's got a little board in it, which I like, because what it's then done is, since the 40-pin connector, amongst other things, is being routed through here, it's able to tap off of the 40-pin connector the right voltage for the fan. And it gives you a little jumper here. You can switch from one position to the next to indicate how fast you want the fan to turn, right here. So it's a standard little jumper. They used to use those a lot in traditional computer systems from years gone by. You get to pick what they've defined as a default default or an always on. The case itself is aluminum, so what it's doing here is it actually connects these little extender pieces of metal that's coming off of the case itself through that little board. It also have some of these heat transfer pads. Yeah, it does. It's got, and it looks like 2 heat transfer pads for the 2 chips that this would coat on top of. So one circuit board came installed, the other one doesn't, because it has to go into the Raspberry Pi first. This circuit board, I don't believe has logic on it. We'll see if anything shows. But what it does is it reroutes some of the critical cables. So this plugs into the Pi like this. So you have the 2 HDMI connectors and you have the sound connector, and then it reroutes them on this board through LANs. I don't see necessarily any logic on it. It just reroutes the LANs, I believe. It reroutes them over to the back of the case. So what this will do, it'll take the Raspberry Pis, those connectors, and it will make them available out the back like that. But it is a really sturdy, pretty hefty weight aluminum case. The case becomes the heat sink. So that's an important thing to understand. Even though there's a fan, the case becomes the heat sink for the other ICs that are in there. And then this, of course, plugs into the 40-pin I/O connector, and it reroutes that to the top. This case does rerouting of all of the cables, sort of. So that's what's in the box. The next step is to get the Raspberry Pi installed in here and make sure it works. Okay, I've taken the Raspberry Pi out of its case. That last one that I did, I probably should have videoed it, but I thought it would be pretty straightforward. And it was for the most part. However, getting these 2 heat sinks off of the processor and memory, which are the ones that are going to wind up being cooled by the case, getting those 2 off was not easy. And in order to get, you got to like twist it back and forth several times, and then you got to sort of really push it off to the side to get it off. The same thing with the one that's on the memory chip. The way it's going to work is when this goes inside the case, it's going to go in like this, and the 2 chips that will actually touch these 2 risers to the case will be the CPU and the memory. Now they give you these 2 thermal pads with sticky on one side that we have to put on the case. And those will actually make sure that the contact is made between these risers and the chips that they are protecting. And then you got to take these 2, you take the Raspberry Pi, and you've got to connect up this sideboard. Goes into the audio jack and then into the 2 HDMI connectors. Got to be very careful to line it up. There we go. Looks better. That seems to look better from the bottom. There we go. Now I got it pushed all the way in. Right, there we go. That now is pushed all the way in. So now the sideboard is on. And then at this point, we've got to put this Raspberry Pi into the connector. That's where the effort is going to be. So the 40-pin I/O connector has to go into the, this is male, it'll go into the female. Oh, and the fan, they're here. I'm going to put it in default. So the pins are numbered 1, 2, and 3. If you look very carefully there, right underneath those 3 little pins. So I'm going to make sure that it's on 1 and 2, which according to this is the default. But now that that's like this, now I can lay the Raspberry Pi and the sidecar, I'll call it the sidecar, into here. And you have to get it inside this 40-pin connector. That's where the real mechanical strength of the connection happens to be. That's a little bit tricky, huh? Well, you know what it is? I got a bent pin. Don't know how that happened or when that happened. Maybe I just did it. But if there can't be any bent pins in this connector. So I'm straightening it out. They're not sensitive pins. They're pretty solid. We don't want to, obviously you want to bend them back and forth too much, but a little bit of bending shouldn't hurt it on the Raspberry Pi. So now let's see, maybe when I was trying the first time, it didn't quite go in, and it went right in now. So now we're good. And they tell you to take these shorter screws that are here, and they're going to go into the sidecar, mostly. One goes into the actual Pi itself. So there's one that goes here. Won't go all the way down, just enough. One goes here. Another one goes here. And then the final one actually goes into the Raspberry Pi, this connector right here. So the case does not have anything that goes into this one. Go into that corner of the Pi. And now I'll tighten them all down. At this point, I'm going to start initially by putting the SD card that I had in there for the Pi just to test it, and then we'll make the one that's for the Ubuntu. So now it's back to the way it was with the software I had in it, which it should work fine. Wait, let me put this back on. So the back of the case goes this way, and there are 4 screws that connect to it. They're longer screws back here that connect to that. As usual, a magnetic screwdriver helps a lot. Having all your screwdrivers that you use for this kind of work as magnetic would really be helpful. And now we can get this SD card in here. And then these things here are the feet, 4 little rubber feet. It's not meant for being mounted on a wall. It's meant for just lying down just like this. And all of the wire management is very easy and looks professional, like this is a real computer console. So I like the look of it, and I can get to everything back here. Now I did look up what I have to do to get this button to work, the power on button. And there's special software that I've got to download from the website for the Argon. That's once you have the thing up and running. It's geared towards the Pi software, the Debian Linux. So we'll have to see. It may work fine with regular Ubuntu Unix. Linux commands like that, and I copied the shell script. I'll show it on the screen right now. And as you can see, the shell script, it's a standard Unix/Linux shell script. It has a lot of very cryptic command line steps to it. But it is actually downloading some special software that'll actually run inside of the Linux operating system that will respond to that button properly. So I'm going to definitely load it on when we get the Raspberry software up and running again. And then once I put the Linux, I mean, it doesn't hurt. I can always recreate the Linux install SD card. So I'll try it on Linux and see if it works as well. But I do want to make sure that that button does work. And I think that does it. So now I'll show you a screen capture of my PC creating the Linux SD card for this. And then once I got that created, then I'll boot this guy back up into Debian version of Linux, make sure it works, and then we'll switch over to the Linux. Here we are at the raspberrypi.org downloads directory. And as I said in the introduction, I'm going to show you the long way to do this, even though they have in their imager a quicker way. So I'm not going to run the imager this time because it doesn't give you a full selection. Instead, I'm going to come down to the bottom here, and I'm going to pick Ubuntu Server. I'm going to click on that, and it shows all the different versions of Ubuntu that are available, 18.04 and 20.04. I want 20.04 for Raspberry Pi, and I want the 64-bit version. They give you some description here of which versions to pick depending on what you're doing. So I want the 64-bit. Click on it. Now it should be downloading. Yeah, it shows down here in the left-hand corner. Ubuntu 20.04 image.exe is downloading. Now as long as you're waiting for that to download, 2 things you need to go out and download from the internet. One is a freeware program called 7-Zip. I have it right here, and we're going to use that in a couple of minutes. And the other one is called Win32 Disk Imager. Both of those are free, and they're very handy, not just for what I'm doing here, but similar things that you would do with other operating systems. So I'm not going to show you how to do that download. It's pretty straightforward. You do have to be administrator for at least one of them, probably both of them, I forget. But it loads into your computer. They're well tested, so I wouldn't worry about them too much as long as you go to the right site, because they have their own sites. It's almost done, it looks like. It's now scanning for viruses. And as soon as that's done, we will copy that over to where I need to store it. Now, it just so happens I've already got it there, but I'll show you what I do with that and how do I get it down. Still scanning for viruses. It's going through the whole image. This is Windows, normally Windows 10. I have the latest build of Windows 10. It has some advanced features on virus scanning. But as long as you're waiting for that, we can go to the next step. If we come into, and I'm using the standard Windows browser at this point. Oh, it's all done scanning. Now you could click here and open file, but I don't want to do that. I want to come over to here. And you see these 3 dots in the upper right hand corner? I want to click on that, and I want to come down to downloads. So right now that's the only download I have out there. I keep it pretty clean. If I download something, I delete them pretty quickly. But I don't even want this. You could click on it right from here if you want, just like we could have done in the lower left hand corner. I want to show the folder. So when you click on that, you will actually get the folder where that stuff is stored. And then this is the actual file that I want to save. I always save it. So I always have the version that I loaded. And the place that I put it at is on my system file storage area. And I have one there called Raspberry. And I made a subdirectory called Ubuntu 20.04 20.04. So I created that subdirectory. It didn't create it for me. And then all I did was copy that file from here to here. So I already have it downloaded. It's a Raspberry image of Ubuntu server. Now you could also go to the Ubuntu website as well. They keep the Raspberry images up there as well, but I decided to pick the Raspberry area because that's probably where most people would wind up defaulting to. So once I have that, I can go ahead and close this. I actually want to delete this file from the, so I right click on it, I delete, and I don't need this anymore, and then I come back to this area here, and I always say X this out so it no longer shows as a download. So now my downloads are all empty again, and I'll close this tab. So we're back here. Now they go through some detailed instructions on what you need to do in order to create the SD card. That's what they're trying to image here with this little pair of icons. But they go through all the steps you need to do. And if you actually go to, we've already did this, we already meet the requirements. I already have a actual USB SD card installed right now. And if I go back to my computers, it's this drive right here, drive F, removable drive F. Shows us 28.8 gig. It's a 32 gig SD card. So I've already got that out there. So when they tell you here to go through these other steps, I will do it in that directory. So right here they have a thing about flashing the SD card from Windows. You can also do it from Mac and from the actual Ubuntu operating system as well. But let's click on Windows and they give you all the steps. Pretty straightforward. They give you the overview here and then I won't read it all to you. You could read it yourselves. And then you click on this, the next. And it shows you the programs you have to run. And guess what? They say use software like 7-Zip, because there are other ones that'll work too. If you have WinZip installed, which is a product you have to buy, then you can use that instead. But 7-Zip works extremely well and it's free. And then after you've run 7-Zip, it unzips the file, because it was actually done in a compressed format as it was stored up on the Raspberry server. And that's how it downloaded it. We have to uncompress it with 7-Zip. And then we have to use Win32 Disk Imager, the second program I showed you over here, to actually take that image and copy it onto the SD card. Or even if it was, the system doesn't know the difference between an SD card and a regular USB drive. To the system of Windows, it looks exactly the same. So we're going to do those steps. I want to go to Drive S, where I stored it. I want to go to my install. I want to go to my Raspberry Pi again. I want to go to my Ubuntu 20.04. This is what I want to unzip. So what I'll do here is I'll run 7-Zip here. And this is the last unzip that I did. It was Sigma NAS, it looks like. So I'm going to go ahead and pick a different directory than that, because this is what that's showing, the directory I last worked in. So I'm going to pick a different directory right here. Click that button. Backing up. Every time you hit this, it goes up a directory. I want to pick Raspberry Pi, Ubuntu 20.04, and I'm going to click on this. So this is the file that's going to unzip. And then I click on Extract. When I click on Extract, it tells me what it's going to do. It's going to take that image and it's going to extract it to the same place, but in a subdirectory called Raspberry Pi /Ubuntu 20.04, the same subdirectory I created, but now it's going to be an unzipped format of it. The rest of this stuff I don't have to worry about. Go. Okay. It's now unzipping that image. I don't know if you can see in the background here. Let me move this out of the way. It's actually creating another folder within that folder called the Ubuntu 20.04 pre-installed server ARM64 Raspberry Pi image. Okay, it's all done. So now I can close 7-Zip. Don't need that anymore. And I can click on this. And as I suspected, it created another subdirectory called Ubuntu 20.04 pre-installed server, etc., etc. And then in there is the actual image file, the .img file. This is similar to when I did the Sigma NAS, because that's the type of file you need to then take and either put on a DVD/CD. We could do it that way, and you could just use regular Windows to do it if you have a DVD CD-ROM, with the software that came with it in most cases you need. But I think Windows 10 itself includes something that'll work. Or you can use, in my case, which is what I'll use, the Win32 Disk Imager. So I'll click on that next. I have to be administrator, and it automatically is waiting for input. So we have to tell it what device we want to write to. It's kind of small right now. Let's see if I can extend. There we go. Grew it up a little. It automatically picked drive F. It's the only place I have a USB type mounted storage device, in this case an SD card. But now I have to tell it the image I want to do. So I have to click on this little folder here, And now I have to sort of find myself back to what I want. This PC, we go to drive S, we go to install, we go to Raspberry Pi, we go to Ubuntu, and then we have another subdirectory we got to go into here. It's looking for a .image, and only when it finds one will it accept it, and it did accept it. Once I went all the way down into it, I say open. So now it's got an image, now it's got a drive to write to, and really all I have to do here is say write, and write will be write and verify. I could also just read it if I wanted to just verify it with this verify only, but I'm going to go ahead and say write. They ask me if I'm sure because it's going to wipe out drive F. Fine. Okay, it's finally all done. Say okay to this. And now we have an SD card. Let me close this first, exit, and then I'll have to come down here and dismount the SD card. So I want to remove actually, see, I click on that. It's safe to remove. And the light went off on my reader that I have the SD card connected to, and I just pulled it out. So now I have an SD card with Ubuntu Linux that should be pre-configured for the Raspberry Pi. Before I leave this though, you need to read further through this. So once you've gone ahead and made the SD card, as they show exactly what I did, right? Then you're going to have to actually boot it up. So I backed up to this menu here. We had just done step 2. Now it tells you to basically boot the Ubuntu server. And once you boot it, they're going to want you to have connection to the internet. And you log in using the login ID of Ubuntu. And then you'll be asked to change a default password after you log in. So Ubuntu is for both username and password. And now it says you would then be running the Raspberry Pi, and we will try that. They also give you a bunch of other options here, some stuff that you can install, things called snaps that are available. You can buy these snaps, they're all sorts. I'm not going to go through that now. If you want to look at it, feel free. I'm just going to bring up the base server. I'm not going to be using anything that's customized for the Raspberry Pi on it, other than the fact that it is pre-configured for the Raspberry Pi and verified as running on the Raspberry Pi. Okay, now I have it set up so that the Raspberry Pi original SD card is in there, the one that I originally installed into this Raspberry Pi 4. Let me start by just hitting the power button and see if it recognizes it. Hey, it does. It actually, when I clicked on it, it started powering up. Let's see what we get here. I see raspberries. That's good. And there we go. Wow. We're into the Raspberry Pi, the normal Raspbian operating system that Raspberry Pi is primarily meant to run. So if I come in here now, let me click on the internet, see what we get. I guess we don't have a default location here, so the last thing I used was YouTube. That's what it remembers. Let me click on that and see if it goes into YouTube. Okay, we are up. That's good. Let me now go ahead and see if I switch SD cards. Will it still work good? And also I'll test to see if the thing shuts down properly as well. Let me close this window and let me see if I can get this to shut down properly. Close the browser first, and then I'll hit the power button on the back and see what I get. I'll try a long hit, like they said, 3 seconds in the instructions. 1, 2, 3. Powers on and shuts down without any special software added. So that's good enough for me. I'm going to assume that the Raspberry Pi software already has been updated to account for this. Okay, now I've put in the Ubuntu SD card, and I'm going to try powering it on again using the button on the case and see what happens here. It's coming on. I see the red light. See if it boots up now. That's standard Linux coming up. So we're not going to have a nice fancy desktop with this. This is Ubuntu server, so it does not have the desktop with it. It'll have to go only into command prompts. And there we go. Account Ubuntu, password Ubuntu. Oh, it's still running some applications in the background here. Okay, so it took it this time. It wants me to change my password. I guess it wasn't fully up yet when I tried to log in. Let me pick my normal password, and it looks like it took it. Let's see if we can log in now. Ubuntu and my normal password. Okay, let me try it again. Okay, I took several attempts to get it to accept my new password, but it finally did. On this last attempt, it asked me to change it again. I made the password a little more complex. I put special characters and other things into it, and then it asked me to type it in a second time. As you can look up there in the top, it says first new password, then retype new password. And then finally it went up into Ubuntu server. So I think we finally got it going. It took a while. I guess it needed a complex password. It did pop something up very quickly that I didn't see. Probably said I needed a more complex password when I did that. So I'm up in Ubuntu Linux right now, command line only. There is no graphical user interface here in the server version of Ubuntu. I just tested it with a couple of commands and it is working. Let me show you what I did. The first thing I did was I checked where I was at. So it was in home Ubuntu. So right now, let me go back there. That's where it wound up by default. If I say pwd, what directory am I in? Home Ubuntu. That's what it was when I finally got logged in. And then what I did is I switched over to the root directory. I did a change directory cd to /. Now I'm not going to teach you all the commands to Linux or Unix. They're very similar. I just wanted to show you that it is working as a full command line server at this point. If I do an ls-l, list all the directories long form, it's actually list everything, not just the directories. We see that actually all we have here is directories. The ones that have a D in the leftmost character, where it says DRW, those W, X, R, dash, X, those are the permissions for those directories. I'm not going to get into that in detail right now, but most of them are directories that actually exist here. The ones that are in dark blue over to the right, the ones that have like an aqua, and then that's an arrow to a dark blue, shows that it's called something here in aqua, but in reality it's a link to another directory somewhere else. But it is up and running. In a future video, I will go ahead and install Samba on this using the command line and turn it into my backup domain controller. But we are running. Let me see if this thing will automatically shut down when I push the button in for the 3 seconds. I'm curious now. 1, 2, 3. But it looks like we're good at this point. So that's all I wanted to cover in this video. Well, that worked out pretty well, I thought. Everything I wanted to work today worked. A little bit of problem with that password. I had to make sure I picked a complex one. When I go in the editor, I'll double check to see what that little quick blurb of a message popped up as, but that's probably what it's about. Because once I picked a more complex password, then it was happy, and it allowed me to move on and change the password properly. I still have it hooked up here, as you can see. All the cables hooked up. Just one point that I'd take to make. These HDMI cables are no longer next to the power connector. It is still the one that's all the way furthest left from the camera's perspective that you would plug in a single monitor. Obviously, if you're putting 2 monitors, they both be filled. But if you don't pick the right one on a single monitor, sometimes you don't get any screen output, just to let you know. So hopefully you got something out of this video. If you did, please consider subscribing to my channel. It would really be helpful. Again, subscribing does not cost anything, and you only get alerts if you choose alert. But it would really help us. My head will pop up in here in a moment. Click on it, follow along, and subscribe. Anyway, until my next video, take care. I hope everybody's doing well in your family and stays that way. And thank you for watching.